Once, the night sky was a realm of magic, home to gods and goddesses, to mythical beasts, to the unknown and the unknowable. But with the spread of Christian principles, we looked again and we saw the stars through different eyes. It was no longer a place to fear. It was a place of wonder. Hi, I'm Marcus Lloyd, and welcome back to The Universe, a journey through God's grand design. In the last episode, we talked about the earliest days of astronomy. We looked at the contributions of faithful scientists like Copernicus, Kepler, and Galileo. Their biblical convictions led them to believe in a universe that was the creation of a rational God, a universe that we can probe and come to understand. As the Christian worldview reached across Europe, it brought new ways of looking at things. No longer were the heavens the dark and frightening place of our superstitious past. Now we saw order and design everywhere, God's design. Stars moved in a set pattern that allowed ancient mariners to navigate ships similar to this. It was a universe that the human mind could explore and understand. Scientific knowledge went through a period of explosive growth. The invention of the telescope extended the range of celestial exploration far beyond what anyone had anticipated. By the mid-1600s, we knew the basic structure of the solar system. But for the first time, we understood that moons orbit planets and planets orbit the sun in elliptical paths. But we still didn't know why. Scientists of the day couldn't grasp the reason. What force could cause the planets to move as they do? It would take some creative biblical thinking to answer that question. Today, we're going to look at one of the most brilliant men in history, Sir Isaac Newton. His work broke barriers and broadened our horizons. It was a turning point in the history of mankind, and it marked the birth of modern science. Newton's discoveries would eventually allow humanity to build craft that would actually travel into space.
Roger, the clock is operating. We're underway.
This one man set us all on a whole new journey. Born in 1642, a year after Galileo's death, Isaac Newton was intensely private and reluctant to publish his remarkable discoveries. His friends loved him, and his detractors hated him. But few could doubt that he was one of the greatest minds the world has ever known. Newton focused his studies on calculus, optics, the laws of motion and gravity. He also passionately studied the Bible, particularly the prophecies of Daniel. He spent his spare time reading philosophers of the day and kept a set of notes where he jotted down questions from time to time.
Isaac Newton was simply one of the greatest physicists who ever lived. He made tremendous contributions to mathematics and physics, particularly in the development of calculus. Newton formulated his 3 laws of motion as well as his law of gravity, and these are very simple rules. You can write them down on an index card, but if you follow them through to their conclusion, you can use them to send astronauts to the moon. They are that powerful.
A body at rest tends to stay at rest, and a body in motion tends to stay in motion unless acted upon by an outside force. The acceleration of a body is equal to the force acting upon it, divided by the body's mass. For every action, there is an equal and opposite reaction.
Newton was very interested in astronomy. It was a fascination of his. And when a comet appeared in 1680, it reignited his interest in astronomy. He had already read Kepler and Galileo, but at that time, they still didn't know why Kepler's laws worked. What was the underlying mechanism? Newton set out to answer that question.
The breakthrough came, of course, when Newton saw an apple fall from a tree.
Why should the apple fall directly down and not in some other direction?
Sounds like a simple question, but the answer changed the world.
Assuredly, the reason is that the Earth draws it. There must be a drawing power in matter, and the sum of the drawing power in the matter of the Earth must be the Earth's center, not in any side of the Earth.
The mass of the Earth exerts a force on the apple, an attraction called gravity. But wouldn't the pull of gravity extend out into space? Why doesn't the moon fall towards the Earth's center, like the apple? Leave it to Newton to figure that out.
He's sitting under the apple tree. The apple falls to the earth, and he wonders, why doesn't the moon fall to the earth the same way the apple does? he set about to answer that question. Now, if you were to take an apple and throw it some distance forward, it would not fall straight down, it would form an arc. It would hit the earth, but it would hit it some distance away. Imagine if you threw it really far so that it was actually out over the ocean before it finally touched the surface of the earth. Well, since the earth curves, the earth is round, it's actually curving away from the apple as it falls, and so the apple will hit at a lower distance than where it was first launched. Now imagine you threw an apple so hard that it fell at the same rate that the earth curved away underneath it. In that case, the apple would never get closer to the surface of the earth. It would make a complete loop and come back to its point of origin. That essentially is an orbit.
Newton realized that the moon does the same thing. It goes around the earth for the same reason. The moon is like that apple. It's moving so fast it would go in a straight line, disappearing out in space. But Earth's gravity keeps pulling at it. Gravity makes it move in a loop around us. It falls just like the apple, but the moon is falling around the earth.
Sometimes gravity is called the glue of the universe. It holds everything together. It keeps the moon going around the earth, it keeps the earth going around the sun, and it keeps the whole Milky Way galaxy revolving, tightly held together by gravity. The moon and the earth are tied together by gravity. The gravity force keeps the moon in its orbit, and of course the moon pulls back on the earth and causes the tides. Now, gravity is a bit of a mystery. It's invisible. We're not quite sure what it is, but it acts all the time. It even holds us on the ground as well. And between the Earth and the Moon, it adds up to a very large number, millions of tons of force.
Newton's laws of motion and gravity can be used to compute the motion of almost everything in our universe. For the first time, scientists understood why planets and moons move the way they do. Still, Isaac Newton remained modest about his many achievements.
If I have seen further, it is by standing on the shoulders of giants.
He must have seen a lot because he managed to set science on a whole new course. This was the first time that physics on Earth had been applied to outer space. Many ancient cultures believed that space was divine and obeyed different rules. But the Bible teaches that Christ is Lord of both heaven and earth. The Christian worldview says the whole universe, here and above, submits to God's power. So, everything obeys the same laws. Newton understood that God was behind all of this.
Gravity explains the motion of the planets, but it cannot explain who set the planets in motion. God governs all things and knows all that is or can be done.
When Newton published his book, his friend said, "Well, Isaac, you've done it this time. You're explaining everything. We don't need God anymore." And when Newton heard that, he spoke right up and said, "That's not what I did at all. I'm showing you how God put it together. God's revealing to me his handiwork." In other words, Newton was a godly man. He had a great respect for Scripture and his maker. In fact, Newton wrote more theology than he did science. He spent a lot of time studying the Scriptures.
Newton literally wrote the book on physics in his Principia, but he followed that a couple of decades later with his work, his great treatise on optics, and it became the standard text for 200 years. Much of his book was about how the light is actually a wave. You can break its light up with a prism into shorter and longer wavelengths or different colors from violet to red.
He also found that you can recombine those colors into white light again using lenses. And this answered a long-standing problem that astronomers were having with their telescopes. Up until that point, all telescopes used two lenses and to bring light to a focus, and that's the way they were able to magnify objects.
And one of the problems we've had from the very beginning with telescopes, ones that use lenses, is a problem called chromatic aberration. The lenses themselves would act like prisms and would split the light and make a little rainbow hue. It's kind of pretty, but on the other hand, it blurs the images terribly.
This chromatic aberration produced a purple halo around planets and stars, making good observations difficult. For years, astronomers struggled with the problem. Then, Newton fixed it. He replaced the primary lens with a mirror, a polished, rounded metal mirror. Glass bends different wavelengths of light by different amounts, but a polished surface will reflect all wavelengths equally. In theory, using a mirror should eliminate chromatic aberration. Pure silver was expensive and corroded quickly. So Newton experimented with several other substances before settling on 6 parts copper and 2 parts tin. The result was almost as bright as silver and reflected plenty of light. Now this was important because the more light that was reflected, the better the view. Newton's telescope completely eliminated the purple halo, resulting in images of perfect color. Newton had demonstrated the potential advantages of the reflecting telescope. Over time, telescopes would come to use glass mirrors with coated silver or aluminum on the surface. These are easier to grind and further improve the quality of images. But the basic design of the Newtonian telescope is still in use today. The poet Alexander Pope said, "Nature and nature's laws lay hid in night. God said, 'Let Newton be,' and all was light." By the late 1700s, a lot of astronomers were using Newtonian telescopes, resulting in many new discoveries. William Herschel was a British astronomer who constructed his own version of the telescope. Along with his sister Caroline, he began a search for binary stars in 1774. These are 2 stars in orbit together. To the eye, they look like one point of light. Through his telescope, Herschel saw that they were separate stars. He discovered several hundred of these binary star systems.
He made lots of discoveries, one of which he realized that some of these cloud-like objects seen in the night sky, what we call nebula, some of these were actually clusters of stars. That was a hint that there might be other galaxies out there.
He also looked at many stars, trying to figure out if there were binary stars. These are 2 stars orbiting one another.
The discovery of binary stars and the way they orbit each other shows that Newton's laws work in deep space just the same as they do on Earth. This led to even more discoveries. Astronomers would eventually use Newton's laws to compute the mass of binary stars, or how much material they contain.
When we want to find the mass of something, we usually weigh it. You step on the scales in the morning, and if your weight went up, that's a force of gravity between you and the Earth. It's probably your mass that is accountable for this. Now, you could ask, well, how do we find the masses of stars? Well, if we had some scales big enough, we could have them stand on it, but that's not very practical, is it? So what we do instead is we measure, again, the gravity, but this time it's the gravity between 2 stars in a binary system. They attract each other by their mutual gravity, and the motions they follow, the orbits they follow, depend directly upon that gravity, and from Newton's law of gravity, we can figure out what the masses are.
While searching for double stars, Herschel made a discovery for which he is most well known. He noticed a small blue disk. At first, he thought it was a comet. The object moved slowly from night to night like a comet would, but it lacked the usual fuzzy appearance of a comet, and there was no tail. He saw that its motion was a nearly circular orbit, more like a planet. Herschel realized he had discovered a new planet beyond the orbit of Saturn. This was the first planet to be discovered since ancient times. Our ancestors, all the way back to Adam and Eve, could see 5 planets with their naked eyes: Mercury, Venus, Mars, Jupiter, and Saturn. In time, people came to understand that Earth is a planet as well. But William Herschel found one more, a planet that you can't see easily with the naked eye. Following tradition, the planet was named for a mythical god. It was called Uranus, after the Greek god of the sky, because of its light blue color. Later, Herschel discovered 2 moons of Uranus, Titania and Oberon.
By the mid-1800s, astronomers realized that the orbit of Uranus seemed to deviate slightly from what was predicted on the basis of Newton's laws of motion and gravity. Now, Newton's laws of motion and gravity had been very successful in accounting for the motions of the other planets in the solar system, so it seemed likely that those laws were correct. But what could account for the unusual motion of Uranus? 2 mathematicians independently realized that another planet orbiting beyond Uranus could cause Uranus to move that way by pulling on it with its gravity. Urbain Le Verrier and John Couch Adams independently worked out the solution to this problem and found that yes, indeed, there must be a planet orbiting beyond the planet Uranus, pulling on it, and they computed the position of the as yet undiscovered planet. Le Verrier mailed in his prediction to the Berlin Observatory, and within one evening, astronomers there were able to locate this new planet, which we now call the planet Neptune, and it was within 1 degree of the coordinates that Le Verrier had predicted.
The discovery of Neptune was a triumph of Newtonian physics. It was hailed as one of the greatest scientific discoveries of the 19th century. Using Newton's laws of motion, his law of gravity, using calculus, mathematicians were able to find a new planet. This wasn't an accidental discovery with a telescope. This was a search made with mathematics, with calculations on a sheet of paper. Because of this, Leverrier was called the man who discovered a planet with the point of his pen. So astronomers finally understood why stars and planets move the way they do, but they hadn't yet figured out what stars are. Before the influence of the biblical worldview, people believed that stars were divine. It was considered bad luck to point at a star because, as they saw it, you were pointing at a god that could anger the spirits. In some cultures, it was even believed that pointing at a star could cause a person to die. There were some who believed that shooting stars held the souls of the dead, or the soul of a new life coming to earth. But the Bible teaches us that stars are creations of God and aren't things you worship or fear. In Jeremiah 10:2, we're warned against this kind of superstition. Thus says the Lord, do not learn the way of the Gentiles. Do not be dismayed at the signs of heaven, for the Gentiles are dismayed at them. It would take a whole new field of science before we actually began to understand what stars were made of.
Newton's discoveries in the field of optics paved the way for an entire new branch of astronomy, which we now call spectroscopy.
One of the pioneers of this field was a German physicist named Joseph von Fraunhofer. He invented a device that split white light into a spectrum of colors with a much higher resolution than a prism. Fraunhofer found that when he passed sunlight through his spectroscope, the spectrum had small black lines in it. Apparently, some wavelengths are missing from the sun's light. It seems every light-emitting substance produces a unique spectrum, a sort of atomic fingerprint. The field of spectroscopy allows us to identify the composition of any such substance.
As you got into the part of the 19th century, people began to realize that these different spectral lines were due to different elements. Hydrogen would produce certain lines, calcium, other lines, iron, other lines. And so this allowed us to do a lot of things. First of all, it allows us to figure out what the stars are made out of. That understanding really wasn't finished until the early 20th century.
Once scientists understood this, new doors were open to them.
Just by the type of light that is emitted and breaking it down into a spectrum, we can identify the composition of anything in the universe. It's a wonderful thing that the Lord has constructed the universe in that way, that the objects themselves, stars, give information about what they're made of.
So we know today, for instance, the sun is about 75% hydrogen, about 1/4 helium, and a few percent everything else. And that's pretty common among the other stars, but you can learn many other things. You can look at what's called a Doppler shift. If a star is moving towards you or away from you, those spectral lines are shifted to different ends of the spectrum, towards shorter or longer wavelengths. And if we measure that, we can figure out how fast things are moving toward or away from us. That's been very important in modern cosmology. If we didn't have spectroscopy, again, we wouldn't know much about stars.
Spectroscopy showed differences between stars, too. Certain features were strong in some and weak in others, but no two stars were the same. This confirms what 1 Corinthians 15:41 was teaching us all along. There's one glory of the sun, another glory of the moon, and another glory of the stars, for one star differs from another star in glory. When ancient cultures looked at the sky, they were overwhelmed by its mysteries. They created gods and monsters to explain what they saw. For centuries they observed, but they didn't understand. But with the spread of Christianity, things began to change. Christians eagerly accepted the challenge of understanding the stars. Believing God designed the universe to have order and rules, the early Christian astronomers watched the way the earth, moon, sun, and stars move and tried to figure out those rules. That's what science is all about, trying to understand the patterns that God imposed on His universe. God gave us intellect, and He wants us to use it to explore His creation. And what we have found confirms again and again the truth as revealed in the Bible. God upholds the universe in a consistent manner that we can understand through science and mathematics. Every new revelation leads to new questions because God delights in taking us on this voyage, this quest for knowledge. The further we venture into space, the more He reveals to us. I'm Marcus Lloyd. Thanks for joining me. On our next episode, our journey will take us into the 20th century, and we'll see some really exciting discoveries.